and start recording. Okay. Module 4 and 5 are due next Tuesday. 2 and 3 are due today. Module 6 and 7 is due the 15th. And then you'll see that there's a knowledge check and a review module. So our exam over modules 1 through 7 would be somewhere around the 16th to the 20th in that frame. What I'll probably do is review before, and the test will be closer to the 20th. But any questions so far? If you haven't started working on Alex, please make sure you start. There's 4 people that 2 haven't taken the knowledge check and 2 have taken it but then not done anything. So you're getting behind quickly. Is there any questions? No questions? Okay. Looking at Alex. Let's see. Would you have the test? What I might do is part of it will be due on Friday, and there might be a part that's timed. And then I have a written part also, and you could do that maybe Friday through Sunday as long as so if you don't want to do it on the weekend, that's fine, but if you'd rather have more time and do it on the weekend, that would work also. So some of the longer problems, I don't know if we have too many longer ones, that I want to see worked out will be on one part, and then there'll be a timed one, solve an equation and you type in the number, where they're easy ones to answer. Not necessarily easy, but they're one value. You're not typing multiple things in. That will be timed.
Are we solving inequalities and so?
Yeah, there is inequalities on, I think it's, well, module we're doing right now, module 4.
Okay, good, because I'm kind of having trouble with that.
Okay. There's a lot of people on that, and that's actually what I was going to cover today. I also made a video on it. I don't know what was going on last night with Blackboard, but I recorded, I think it was 6 hours worth of things, and they didn't even come down till early this morning. They were still uploading when I got up at 6 this morning. I don't know what happened, but so it's taking a little longer on these than I thought. But I recorded the inequalities. There's a few more I want to record, and then I'll put them all up there for this week, today, hopefully. Oh no. I think that there's so many people using the system that don't usually use it. And it just said that there was a weak connection. Can everyone hear me? Okay. I'm going to switch to my, well, all right, if you can hear me, then I'm not going to move anything. But with everyone using all these things that haven't been using it all summer, they're not used to it because there's so many people online right now, and everything's crashing. But it's starting to get better, so be patient and make sure you hear Alex. That's the biggest thing. I try not to give this class discussion boards and things like that because I want you to do your Alex. Okay. Problems. Let's go through the problems, which should be up here, Alex. Okay. Now, these are ones we've done already in this top part here. But it says there's not as many people Most of them have already done these. Here's the largest group is ready. These ones here, 71, 96, 89, we're ready for these. And that's what I thought we should go over. It's the inequalities. We did the first one, and I think we might have done this one. Let's see what it is. This is the homework. I mean, what is homework? This one's or. When it is or and when it's and, they're two different things, and you want to be careful of that. There we go. Or means both of them, all of them put together. So you're taking everything greater than or equal to 7, everything less than 2, and you're combining all of it. It can be in either one. So when we have x greater than or equal to 7 or x less than 2, you can just draw it right on the number line and let them overlap because it's everything that they include if they do overlap. 2, 7, greater than or equal to 7 would mean including it. So we color it in, and everything greater than. Less than would mean an open circle because we're not, doesn't have the equal sign, and everything less than. Oops. Move this down a little more. I'm going to do the inequality, or this would be the inequality, the graph of it. Then there's also the interval. When you write the interval, this is negative infinity this way, so it's going from negative infinity to 2. It's not including the 2, so it's a parenthesis. And then it's going from 7 to infinity because it's starting at 7 and it keeps going. It's including the 7, so it gets a square bracket. And then it's an or, depending on what section it's in. Usually you should use a U for union, but sometimes Alex just says to put a space there. So I'm not sure if it'll have a space or a U or an or. But just the directions will tell you. Use a U to separate them, use a space. Let's try, I want an and. Let me find an and. Or and. Okay, so we have an and. 8 less than or equal to, I'm flipping it. X less than or equal to 8 and x greater than or equal to 5. Now on this one, an and is only where they overlap. It has to be in both of them. So when we graph it, I always graph it above the number line first and see where it overlaps. So less than or equal to 8 would be here, including it, so it's colored in, and everything less than. Greater than or equal to 5 would be at the 5, including it, because of the equal to, and everything this way. And means only where they overlap. So my final answer goes from 5, and it's including because it's in both, and 8 is in both. Everything in between. Thought I heard. My screen froze. Let me switch my internet real quick. So many people on the internet. Let's see if that works better. Alex does not suck. Actually, Alex is one of the better systems, I think, because you go at your own pace. If you're ahead of people, you're not getting held back. You can get them finished. I think Alex teaches you more than any other platform, because I am not a computer platform. I do not like online homework, but I do like Alex. My other class, my math lab, I don't like it at all. And I'm using a Wiley at another place, and I don't like it. So Alex is a good one. But I'm working now. Oh, yeah, they all have bugs. Definitely.
Yeah, the screen is working now.
Okay. So let's bring that back up. Okay. Now you saw the one before, right? It just froze on this one.
We saw the one before.
Okay. And so because these were both equal to, that's why our dots are both colored in. Less than 8 would be this one, greater is this one, and we only want where they overlap. And they overlapped from 5 to 8. So this would be your inequality. This is your graph. The interval would go from 5 to 8. Both are colored in, so both get a square bracket. Any questions on that? Positive. Okay, let's solve some now, because you have to do that same process in solving them anyways. Alex. Solve. There we go. Now, when you're solving them, you need to be careful when you multiply or divide by a negative. Because if we need, this one doesn't, but if we needed to multiply or divide by a negative, we need to flip that inequality. But it's only when you multiply or divide both sides by a negative value. And if one doesn't pop up in the first two, then we'll make one up that does. Okay, so if we have x over 2 minus 6 less than or equal to a negative 9. We just solve as if it was an equal sign. What's the first thing we would do?
Add 6.
That's what I would do. If you wanted to get rid of fractions, you could, but since it's only on the one with the variable, it solves pretty easily without getting rid of it.
I don't know who else is in here. I don't know if anybody else found it. There are people in here.
There should be. Wait a second, let me go back. Yeah, there's 30 people.
There's 3 people in here.
Yeah.
Okay.
They just like to be quiet. But anytime you want to say something, just unmute yourself and say it. If you have a question on something.
Yeah, for sure.
Okay, so we subtracted the 6. No, we didn't. We added it. We added the 6 and got a negative 3. Now we're getting rid of this 2 in the denominator. Since we're dividing it, we multiply. Always do the opposite. So we're multiplying both sides by a positive 2. The inequality stays the same. And negative 3 times 2 is a negative 6. So our answer is x less than or equal to negative 6. And you didn't need to graph it. If you were going to, for practice, negative 6, it's including it, so it's colored in, and it's everything less than. Now, if you always put your variable first, then this arrow will point the same way as this one. But you have to have the variable first. Interval notation, negative infinity to negative 6. It's including this -6, so you get a square bracket. See if we can get a -1.
Why is it 2 over x divided by 2?
Okay, so I had this, and I
Mm-hmm.
wanted to get rid of the 2, so I
Oh,
multiplied both
okay.
sides by the 2.
Okay.
Any other questions on that one? In this one, we want to get 2x by itself, so how would we get rid of the 5? Add it. So we have a -2 less than or equal to 2x. And then we're going to divide both sides by 2. Now, when you're thinking of if I'm multiplying or dividing by a negative, the value you're looking at is the one you're doing to both sides. So since these are both positive, the inequality stays the same. We have a -1 less than or equal to x. And when you're graphing it, if you want to make this point the same way as the arrow, when the x isn't on the left side, you can just flip all of that. So x greater than or equal to -1. That way then we know that it's going to go to the right. But that's up to you. You don't have to.
If you wanted to, could you flip the sign and just put the x on the other side? Like make it completely
Right.
flip?
That's what I did here. I took this one and I flipped it.
Oh, okay.
So we go from -1 and we're including it. And we want everything greater. And interval notation would go from -1 and it keeps going to infinity. Infinities always have a parenthesis. This one's colored in, it gets a square bracket. Any questions on that one? Okay, let's do one. -3x minus 4 less than 5. Okay. There's no negatives in this one, I don't think, but then they pop into another one. So I want to do one just to make sure we have some in there. And when we go to solve this, we want to get the -3x by itself first.
So add 4.
So add the 4.
And then 9.
-3x is less than 9.
We divide by -3.
Yes. Now, since we're dividing both sides by that negative, that's when your inequality flips. So then we have x, and this flips.
So only for dividing by a negative.
Multiplying or dividing both sides by a negative.
Okay, then the inequality flips. Okay.
So x is greater than -3. The graph. Notice this one doesn't have an equal to, so it's an open circle, and then it's everything greater. So when we do the interval, it goes from -3 to infinity, and it's not including the -3, so it gets a parenthesis. So when it has the equal to, it's colored in and it's square. When it doesn't have the equal to, it's open and it's a parenthesis. Any questions on those?
No.
Everyone's good. Let's try the next set. Let me close it first. Alex. Now this one just takes the two things and combines them together. Two x plus 2 less than or equal to 0, or 3x plus 5 greater than or equal to 20. So or means you take both, everything, and is only where they overlap. So if we solve this, subtracting the 2, we have 2x less than or equal to a negative 2, and then we divide by 2. So that x is less than or equal to a negative 1. And the next one, we subtract the 5. 3x greater than or equal to negative 3, and then divide by the 3. Make sure I wrote it right. Negative 1. Oh, this was 20. Oh, well, just in case you wrote 20. I like the way it ended, though. So this was a 20. Be careful of that. Minus 5 would be 15. Dividing by 3 would be 5. So when we graph it, because of the or, you can just graph it all on the number line. You don't have to see where they overlap. Less than or equal to negative 1, equal to, so it's colored in, and everything less than it. Greater than or equal to the 5. So that would be our answer. They wanted us to graph it. Okay. Interval notation would be negative infinity to negative 1, including the negative 1. Union for or. And then from 5, including 5, to infinity. It's easier to do the interval notation once you do the graph. So I always do my graph. Even if I don't have to graph, I do it before I do interval notation. It's just easier to write it. Any questions on that one?
Can we just do one more of that?
Oh, definitely, because I want to do an and also. Okay. Wait, that's the same problem. Okay, let's try another one. There we go. So 2x plus 2 less than or equal to 10, and 2x minus 1 greater than or equal to a negative 3. So you solve both of them separately first. We would subtract our 2. 2x less than or equal to 8, and then divide by 2. Everyone's okay with the solving part. I'm not going too quick with that part, am I? If I am, just ask me to slow down. Then we have an and. We're adding 1 to get 2x by itself. It gives us a negative 2. Then we're going to divide by 2 so that x is greater than or equal to a negative 1. Now, because this is an and, it's only where they overlap. So we're going 4, negative 1, equal to So it'll be colored in, and it's everything less than. This one is -1 and everything greater than. So it's just where they overlap because it has to be in this one and this one. Since this is colored in, it's in both points, so we'd color it in, or both lines. Same thing here, and then everything in between. So it would be from -1 to 4. Any questions on that?
So this is just hypothetically. Is there ever like no solution to this, where like they just don't meet at all, or no? They always
Yeah,
connect. Oh, okay.
yeah. Let's see, x less than -1, and they're not in this section, but they come up. X greater than or equal to 2. So if we go to graph this, -1, so it'd be an open circle because it doesn't have the equal to, and it wants everything less than it. Over here we have the 2, we're including it, but we want everything greater than. So since these two do not overlap, there's no solution. And what Alex asked for, at least in this group, is the empty set. So it wants you to put the empty set. And it says that. It says if no solution, use this, and that's the empty set. So they definitely could do that. They could also, on an OR, be the entire line. If we had x less than 3 and x greater than or equal to 0 with an OR. An OR is everything that you have. So if we look at 3, we're not including it and everything less than. So it's going this way. But this one's saying from 0, including it, and everything greater. So it's overlapping that, and you end up, because it's an OR, you have the whole line. So it would be -infinity to +infinity. They're not in this section. It's either the next section or the following one. So you could have no solution and you could have a whole line. No solution only happens when you have an and. Sorry, I didn't have the problem showing. No solution only happens with your and the whole number line only happens with an or. Any questions on that part? Is everyone okay with these, or do you want to see another one?
No, I think these are good. I just wanted to. Yeah.
Okay. Does everyone agree with that? Oops, Alex. There we go. Okay. So the next group, I think we're on this one. Yeah. Solve the compound inequality, write it in interval notation, and if there's no solution, enter the empty set. So 3, and these are very similar things, which is nice because then you can quickly go through them. And the other part of this section is absolute value. I don't know why I put Y's instead of, those are V's. They look like Y's. Okay, less than or equal to 22. So solve both of them, and then we have to write it in interval notation. We're going to add the 6 and get 3v less than or equal to negative 12 and divide by the 3. The big thing you want to be careful of on these is or and. Add the 2 to the other side. Less than or equal to 11. Oh, it's, no, 10. Okay. I was dividing. So we have a minus 2. We're adding 2. You get 4v is less than or equal to 24, and then divide by 4. That sounds better. V is, are you getting less than or equal to 6?
Yeah.
Now we have to write the inequality, but looking at it like this, it's not as easy to write. That's why I always graph it first. Now, or is just where you're overlapping, so you can just graph both of them on a line. At negative 4, we're including it because of the equal to, and we want everything less than. At 6, we're including it, and we also want everything less than. So it's going this way. So then notice that it's going from negative infinity to 6, and we're including the 6. Any questions on that? Try another one.
Yeah.
Okay. Oh, this is a nice one. 2w plus 5 less than or equal to 9, or a negative 4w less than negative 20. Okay. So we go to solve. So we subtract the 5 and get 2w less than or equal to 4, and then divide by the 2. Next one, we're trying to get w by itself. We divide by the negative 4, w. Now notice we're dividing both sides by a negative. Did you remember to flip the inequality?
Yeah, I actually forgot.
So we have w greater than 5. So we flipped the inequality because we were dividing both sides by the negative 4. So then we go to graph it. W less than or equal to 2. Oops, let me leave a little space. Here, and we're including it. And then greater than 5 is an open circle. Since it's an or, it would be both of those. Interval notation is what they're looking for. Negative infinity to 2, and this is colored in, so it's a square bracket. Union 5, but it's a parenthesis because of the open circle, to infinity. Sorry about my dog. Any questions on that part?
Nope.
What kind of dog is he? What breed?
I have a husky poodle. That's the lower deep voice you hear, and then the squeaky high voice is a labradoodle.
Aw.
Usually the husky's quiet. She's usually laying down here with me, but she wanted to play and I didn't have time. So
Yeah, still a bit Riley today.
it's probably the mailman.
Yeah.
Okay, let's try another one. I want an and. There we go. Okay, so let's try this one. Okay, again, solve them both. Definitely gives you a lot of practice in solving things. Subtract the 3. 4y is greater than 24. And divide by 4. And do you remember to flip the inequality on the second one when we divide by -3? Since we're dividing both sides by a negative, we have to flip the inequality. Now this one's an and, so we have to see where they overlap. This one says 6 greater than. This one says 3 less than. Notice they have nothing in common, so there's no solution. You would put the empty set. Any questions on that one? Do you need to see another one?
No, I think I understand it at least.
Yeah, I got it as well.
Whoops. Okay. I think there's one more. Oh, we go right to absolute values. There must be more inequalities later because it uses sign analysis, so you probably need more material first. Okay, absolute values. When you're working with an absolute value, and it's weird because I don't understand their explanation. But when you have an absolute value,
I think you have 2 of the 7s, it becomes like a -7 on one side, and then
yeah. Now, when it's greater than, though, it's W greater than or equal to 7, as it has it, and then W less than or equal to a -7, and it's an or. So when this is greater than and you drop the absolute value, you have it greater than or equal to 7 or less than or equal to a -7. Maybe now I see what I just never, whoops, I didn't mean to show another, but just, I think the way they explained this is confusing. When it's less than, so when it's greater than, you break it into two parts, the way it is, and then you flip it and change your sign, and it's an or. Remember that think of it as greater. It has the or in it. But less than, what's this one? X less than or equal to 6. I just rewrite this because this is less than. It becomes -6 less than W less than 6. Because notice that the graph's in between.
I mean, whenever I see an absolute value x, I just straight away know it's like -6 on one side and 6 on the other.
Yeah.
And depending on whether they're equal to or not, I shade them, and that's it.
You just have to be careful with the inequalities. When it's in a less than, like this one is, we use this. But when it's a greater than, you write it this way.
Yeah.
So just be careful. Let's get rid of the explanation and try another. Okay. Oh, I guess they don't have too many examples. There we go. Okay, so try graph the solution to the inequality on the number line. So we have y less than 2. So the absolute value of y is less than 2. Less than means we can rewrite it as -2 less than y less than 2. Oh, no problem there. There we go. So the number line goes from -2 to 2. It's not equal to, so they're open circle. So when it's less than, they will be in between. Same thing here, this would be in between.
I think you accidentally stopped sharing your screen, or maybe that's just
Yeah.
maybe me.
Oh,
It's the same for me, yeah.
I wonder if I hit something. It did stop. The time, oh, it's not the end of time. Sorry about that.
No worries.
I usually hide that so it won't do that. Okay. So this one we had less than or equal to, so these should be equals. And these would be colored in. So notice when it's less than, it's in between. Whereas if we look at the one above that was greater than, these are going to go in opposite directions. Greater than or equal to 7 goes this way. Less than or equal to a -7 goes this way. Because then in the next section, they're going to show you the graph and they want you to write the equation. So when it's a greater than, they go in opposite directions. And when they're in between, they're less than. Any questions on that?
Mm-mm.
Yeah, it's not too bad. Let's try the next section. Oh, there's Alex. Moved. See, now they're going backwards. So in this one, they have the graphs going in opposite directions, but notice that they're both at 5. and they're open circles. So we know it will not have the equal to part. So we'll have a 5. Write the inequality, use x for the variable. So we have the absolute value of x. Now we need to decide if it's less than or greater than. Notice they're both going in opposite directions. So it's one or the other. So it's greater than. The ones we had, or the one we had greater than, went in opposite directions. When they're in between, it's less than. So since it's similar to this one, it's greater.
We can't see the problem just because of the out. Oh, never mind.
When I flipped it, it was out of the screen. Try another one.
Yes.
Show another.
Yeah, I think one more. That'd be good.
We'll do this one, and then I want to find one where it's in between so we can just make sure. Oh, that's the exact same graph. Okay, this one's different. So go ahead and write the equation of the line. Absolute value inequality. It says to use the variable of x, so we have the absolute value of x. We know we will have the equal to part because it's colored in. And we're going to have it a 7 because they're both 7s. Now we just need to decide if it's greater than or less than. Because they're in opposite directions, it's one or the other, so it's greater. Any questions on that?
So
No.
anytime both of the rays are facing opposite of one another, it would be greater than. But if they're
Yeah.
intersecting, it would be less than.
Yep. Let me see
All
if I
right.
can find.
Thank you.
You're welcome. Let's see if we can see. These are all. Oh, there we go. So here's one where they're going towards each other. This would be a less than because it's between -5 and 5. So we'd have the absolute value of x. We know it's going between 5, so that's our value. They're colored in, so it has the equal to part. And since it's in between, that's when you use your less than, because less than will be in between. Greater than will go in opposite directions. Any questions on that?
No, it makes sense.
I
Great.
think pretty straightforward.
It's not too bad. Our time's up, which went really quick.
Yeah, it did.
But we covered almost the whole module. I think there's only
Yeah, there's
2
an
parts.
entire module of
So,
inequalities.
yeah.
Yeah,
So that module's not too bad. It's a nice module, better than all those fractions and quadratics.
definitely.
Oh yeah. 100%.
Yeah.
If you do not have any questions, I will see you. I forget when our next class. Tomorrow.
Friday. Oh wait, no,
Yeah,
Wednesday.
tomorrow.
Yeah,
Yeah, we get together Wednesday. Yeah, Wednesday.
yeah. All right, see
All
you
right.
tomorrow. Have a nice day.
See you Wednesday
Alrighty, yeah.
morning.
Have a good day.
Bye.
Thanks, you too.
Bye.
Oh, let me stop recording.